Series is from EduQuest Sustainable Education. We are confident that this video series is going to help you prepare well so that you pass at the end of the year. These questions and solutions are prepared specifically for those who have studied a particular topic and they want to practice more on that particular topic. Today's topic is trigonometry. Trigonometry is an extremely important and large part of paper 2. You must ensure that you master all the basic rules and definitions and be able to apply these rules in many different types of questions. In this session, you will be concentrating on grade 12 trigonometry, which involves compound and double angles. These grade 12 concepts will be integrated with trigonometry you studied in grade 11. Before attempting the typical examination questions, I will summarize the basic concepts in trigonometry. This is a summary of all the trigonometric theories. The first one, as you can see there, sine theta is equals to y over r, cos theta is equals to x over r, tan theta is equals to y over x. You will remember that when you were doing this topic, you learned about 4 quadrants. These quadrants are named in an anti-clockwise direction, starting from quadrant 1, to quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, your sine is positive, your cos is positive, and your tan is positive. You will notice that all three, sine, cos, and tan, they are positive. In quadrant 2, sine is positive, cos is negative, and tan is negative. In quadrant 3, sine is negative, cos is negative, tan is positive. In quadrant 4, sine is negative, cos is positive, and tan is negative. Let's go back to quadrant 1. Our reference angle is angle theta, and every time when we using angle theta, this will be our reference angle. In quadrant 1, we have 90 degrees minus theta. In quadrant 2, we have 90 degrees plus theta. In quadrant 2 again, we have 180 degrees minus theta. We also have 180 degrees plus theta in quadrant 3. And quadrant 4 is 360 minus theta. Let me explain in detail what we mean by this. All angles that fall under quadrant 1, we get them by subtracting from 90 degrees. This is the 90-degree line, which is your y-axis. And then all angles in quadrant 2, we either get them by adding angle theta to 90 degrees or subtracting angle theta from 180 degrees. As you all know, this line is the 180-degree line. Angles in quadrant 3, we get them by adding angle theta to 180 degrees. And in quadrant 4, we get these angles by subtracting theta from 360 degrees. These will help us to understand what we call the reduction formula, which is our next slide. I've got sine 180 minus theta. It simplifies to sine theta. And sine 180 plus theta simplifies to negative sine theta. And sine 360 minus theta simplifies to negative sine theta. You will notice that only sine 180 minus theta simplifies to a positive sign. Otherwise, sine 180 plus theta, which is quadrant 3, when we say sine is negative. So it simplifies to negative sine theta. and quadrant 4 where we said sine is negative, and we get it by saying 360 minus theta. It gives us a negative sign. We go to cos 180 minus theta. It gives us a negative cos. Cos 180 plus theta gives us a negative cos again, and cos 360 minus theta gives us a positive cos. Cos 180 minus theta is in the second quadrant, and we saw that cos is negative in the second quadrant. And cos 180 plus theta, which is in the third quadrant, we saw that cos is negative in the third quadrant. And cos 360 minus theta, which is in the fourth quadrant, we saw that cos is positive in the fourth quadrant. Let's go to tan. Tan 180 minus theta is negative tan. Tan 180 plus theta is positive tan. Tan 360 minus theta is negative tan. We saw that in quadrant 2, which is tan 180 minus theta, our tan is negative. And in the third quadrant, our tan is positive, that's tan 180 plus theta. Then in the fourth quadrant, our tan is negative, which is tan 360 minus theta. Sine has a different 90 degrees has a different effect. Sine 90 degrees minus theta is positive cos, and sine 90 degrees plus theta is also positive cos. As you know, sine 90 minus theta is in the first quadrant, and we know that cos is positive. And sine 90 plus theta is in the second quadrant, and cos is also positive there. Cos 90 minus theta changes to sine theta, and this is in the first quadrant. And cos 90 plus theta changes to negative sine theta. This is in the second quadrant. That's why sine is negative. Sine negative theta simplifies to negative sine theta, while cos negative theta simplifies to a positive cos, and tan negative theta simplifies to negative tan theta. Whenever the angle is greater than 360 degrees, keep subtracting 360 degrees from the angle until you get an angle in the interval 0 degrees to 360 degrees. Let's go on to identities. I've identified two important identities that you need to remember. Sine squared theta plus cos squared theta is equals to 1, and tan theta is equals to sine theta over cos theta. These identities are very important, and you need to always remember them. What you need to also remember is your special angles. Your special angles are your angles 30 degrees, 45 degrees, 60 degrees. Those three are the important ones that you need to remember all the time. In this particular triangle, it's a right angle triangle, as you can see here. This side is 1 unit, and this side is 1 unit, which means this is an isosceles triangle. Therefore, this angle will be 45 degrees, and this angle is 45 degrees. So if we use the Pythagoras theorem, you would remember that we find this side and we get it as square root of 2. This being the case, sine 45 degrees is equals to 1 over square root of 2. Sine being opposite over hypotenuse, I think you remember that. And then we rationalize this, we'll get square root of 2 over 2. Cos 45 degrees is equals to 1 over square root of 2, which is adjacent over hypotenuse, and it also simplifies to root 2 over 2 when we rationalize it. Tan 45 degrees is 1 over 1, which is 1. You would remember that tan is the opposite over the adjacent. Let's go to triangle B. Triangle B, I still have my right angle triangle, but I've got two special angles, 30 degrees right here and 60 degrees that side. My sides, I've got this side which is 1 unit and the hypotenuse is 2 units, and if we use the Pythagoras theorem we find that this side becomes square root of 3. This being the case, sine 30 is 1 over 2, which is opposite over hypotenuse. Cos 30 is square root of 3 over 2, which is adjacent over the hypotenuse. Tan 30 is equals to 1 over square root of 3, which is the opposite over the adjacent. Sin 60 is equals to square root of 3 over 2, which is the opposite over the hypotenuse. Cos 60 is equals to 1 over 2, which is the adjacent over the hypotenuse. And tan 30 is square root of 3 over 1, which is the opposite over the adjacent. You will notice that sin 30 and cos 60, they simplify to the same answer, which is 1 over 2, and sin 60 and cos 30, they simplify to the same answer, which is square root 3 over 2. The following identities are important for tackling your grade 12 trigonometry. We have compound angle identities, and double angle identities. Compound angle identities, there are 4 of them. The first one being sin A plus B simplifies to sin A cos B plus cos A sin B. Sin A minus B simplifies to sin A cos B minus cos A sin B. Cos A plus B simplifies to cos A cos B minus sin A sin B. Cos A minus B simplifies to cos A cos B plus sin A sin B. You will notice that when we are adding two angles A and B, we also add this side when it's sine. When we are subtracting, we also subtract here. But for cos, when we are adding, we subtract. When we are subtracting this side, we add. And notice that cos is cos cos, sine sine, while sine gives you sine cos and cosine, sine cos and cosine. Double angle identities, cos squared theta minus sine squared theta simplifies to cos 2 theta, or the other way around. Cos 2 theta simplifies to cos squared theta minus sine squared theta. Sine 2 theta is equals to 2 sine theta cos theta. I tried to give you other identities that come from cos 2 theta. The first one being cos squared theta minus sine squared theta, as mentioned above, and the second one is 2 cos squared theta minus 1, and the third one is 1 minus 2 sine squared theta. It is important that you remember these formulas because we're going to apply them when we are tackling your past exam questions. Solving two-dimensional problems using the sine, cosine, and area rules. The sine rule can be used when the following is known in the triangle: more than one angle and a side, two sides and an angle not included. The formula that we use thereof is sine A over A is equals to sine B over B, which is equals to sine C over C. Any two of these can help you to solve a problem using the sine rule. Whichever is given, you are going to use any two. If you're given sine A over A and sine B over B, then you use these two, you ignore the c. But if you are given a c and a b, you're going to use sine b over b is equal to sine c over c. You will see this when we tackle the questions. The cosine rule can be used when the following is known in a triangle: 3 sides, 2 sides, and an included angle. And the formula thereof is a squared is equal to b squared plus c squared minus 2bc cos a. This formula, as you can remember, it can also start with b squared, which is equals to a squared plus c squared minus 2ac cos b. Or you can have c squared starting here, which is equals to a squared plus b squared minus 2ab cos c. The third one is the area rule. The area of a triangle can be found when at least 2 sides and an included angle are known. We use the formula area of a triangle ABC is equal to half AB sine C. You would remember that for a right angle triangle we use the simple formula area is equal to half base times height. Thank you very much for listening to our quick revision of trigonometry. Now we go on to the questions.